Hello. We know that learning how to use the oscilloscope is going to be a new experience for many of our students. So we are making this additional detailed description of the equipment and setting up. You should be able to see how we set up all of the equipment on the bench and on the oscilloscope. To start off, we have our digital oscilloscope. This is a voltmeter with a memory, so it shows a running graph of the measurements being taken. Our oscilloscope has two channels, channel 1 and channel 2. On both of these channels, there is a high side, the red, and a low side, the black. These can get rotated around, but regardless of the condition, red is high, black is low. Channel 1 is going to be our main signal, our triggering signal. So for the case of sound, that's going to be the closer microphone. And for the case of electricity, that's going to be the shorter wire. To set this up for the speed of sound, we have our two microphones, and we are going to wire these up to the oscilloscope. For the microphones, the direction of the wiring does not matter. So either side could be high or low, but we want to use our two shorter wires to connect the further back microphone to channel 2 and the closer microphone to channel 1. We can now switch to the oscilloscope to do this setup. On the oscilloscope, there are 4 arrows and 3 dials that we need to control. On the left side, there's a green 1 and a yellow 2. These are the starting positions of channel 1 and channel 2. They can be moved up and down the screen to frame our signal. On the other side, there is this arrow T. That is the trigger. When the signal crosses the trigger, the oscilloscope will take a picture of the signal. So setting the height of the trigger controls when the image will be saved. The orange T up here shows where that event will be framed on the screen. We almost always want to keep it in the middle. Setting up the oscilloscope for the speed of sound, I happen to know from experience that our voltage settings should be approximately 200 millivolts. So the green and yellow dial control the y-axis for our data, and we can adjust them independently. You can either turn the knob or use the drop-down menu to set that scale. Now, we know that the speed of sound is approximately 300 meters per second. So we know that our event that we're going to be measuring will have a delay of approximately 1/300th of a second. So we can set the time axis to be about 1 millisecond to start. We can always adjust that based on our data. Now that our dials are set, we can set our trigger. We want a single event watching channel 1 for the moment that the signal goes up through the trigger. So now we can hit start, and we can see that we are waiting for a signal. When the signal gets made, it will take the picture. We have made the sound and nothing has happened. So we are going to check the trigger level. If the trigger level is too high, then it won't capture. So we are lowering the trigger level, and we'll try again. Now we have our signal. To measure the time delay between channel 1 and channel 2, we will use the cursor, and we would like a vertical cursor. We can click to place the first measurement, and then drag for the second one. And at the bottom, we now see the distance between those two cursors in time. In our case, 1.2 milliseconds. We will then repeat this measurement with different distances between the microphones and get different delays in the signal. For the speed of electricity, we will be looking at a 5-volt signal that is being controlled by a switch. On our 5-volt power supply, there is a side that says ground on a little nub, and the other side is 5 volts. We want the 5-volt side plugged into one side of the switch. Using our short wires again, we want the ground side of the power supply to go into the low side, the black side of channel 1, and we want the other side of the switch to go into the high side of channel 1. So now, when the switch is open, both sides of the oscilloscope read 0 volts. And when the switch is closed, the low side reads 0, and the high side reads 5 volts. That's going to be the signal that we are using for our delay. Along the other channel, we are going to be using a bundle of wire, and we are going to attach them exactly the same way, exactly on top. High side and low side of the power supply. High side and low side of channel 2. So now both signals will go from 0 and 0 to 0 and 5. If you wire this backwards, it will not work. It needs to be 5 volts into the red side of the oscilloscope and 0 volts into the ground side of the oscilloscope. Now, we are expecting a 5-volt signal. So going back to the oscilloscope settings, we can change our volt measurements up to 1 volt height. And we can change our trigger up to about 2 volts. Now, we can try taking this data. We can see here both signals going up, and that delay is the signal we're trying to measure. So let's go ahead and lower this down so we can see the tops of both, and we need to see that delay. So clearly, we are too zoomed out in time to see this signal. So we can start zooming in using the blue knob, increasing and increasing, until we get to this point. We can now see the space between individual data points on the oscilloscope. The way the oscilloscope works is it takes a fixed number of data points based on the window that it has at the moment it took that picture. So if we keep zooming in, we get to the space between data points. But if we now take data again at this new setting, it fills in all that space again, and we can continue zooming in until we lose resolution, and then we can do it again. And now we can see that delay between channel 1 and channel 2. Because we are using an analog switch, just a piece of metal that's moving, sometimes we will not get good data. And that is okay, because we can just take that data again. If we don't like this measurement, can we do better? Can we do better? We'll use that one. We can then use the cursors the exact same way as before to measure that time delay. Once we've completed the first electricity measurement, we need to increase the path length by using another bundle of wires. So we can disconnect one end of the first bundle and attach it directly to one end of the second bundle, and then take the second bundle and add it back into our switch. So now we are going down 2 full bundles of wire, and we can then repeat that measurement as before. Hopefully, this more in-depth look into the equipment and oscilloscope settings of this lab will help you understand how to do this part of it so that you can better understand the physics that we're trying to study. Thank you.